Hello, hello.
Hello.
I think I'm live now with Demoralizer, sir. Uh,
Actually, I don't see. I don't see. I don't.
One second. I think my go live. I have clicked on go live.
Okay.
Hmm.
I don't see it live yet. Oh, I think it is live. Yeah, we're live.
Hello,
Oh,
hello. Like
hi.
people in the chat, can you confirm if audio, video, everything is fine until I verify myself as human? Hello.
Hello. I'm actually reading
Hmm.
the chat on the phone.
Okay.
I don't really see
So,
anyone in the chat.
so today we are planning to discuss code forces around 993. We also have Demoralizer with us to discuss the problems. Okay, so I will take a minute or more, and if everything is fine, then we will start. Mm, everything. Okay, so probably let's start with the first problem for today, which is easy problem.
Yeah.
So the first problem is cube is given an integer n. She wants to know how many ordered pair of positive integers a and b such that a is equal to n minus b. Since cube is not very good at math, please help us. So any idea, demoralizer, how did you solve this problem?
Yeah. I mean, it was just I had to check whether it is ordered pair or unordered pairs, right?
Right.
So if they were unordered pairs, then we might have to consider like 1 and 3 are the same as 3 and 1. So since it is ordered, I knew that the answer is something like n or n minus 1. And I just saw in the sample output that it is every time n minus 1.
Mm.
So I just printed n minus 1.
Right, yeah, like that's what I also did. Like I think when it's ordered pair, the numbers, like for example n equal to 4, we have the numbers like a equal to 1
One in the chat
and
is saying A was the hardest.
yeah, a equal to 2, b equal to 2, and a equal to 3, b equal to 1. Like if it's ordered pair, then these three are different pairs, and
Hmm.
had it been like the ordered pair, unordered pair, then this pair and this pair would have been same here. So like the idea is like we want, since the problem statement says positive numbers, then we know that a should be greater than 0 and b should also be greater than 0.
Yeah.
A greater than 0, a greater than equal to 1, and b greater than equal to 1. And because b is greater than equal to 1, then we know that a is equal to n minus b. This also implies that a should be less than n minus 1.
How
And
to not solve this problem?
yeah, yeah, so overall all the possible values of a we can have here are between 1 comma n minus 1, and there
Hmm.
would be a unique b corresponding to it. So the idea was take n as input and print n minus 1. So any
Hmm.
questions anyone before we go to the next problem?
Yeah.
Yeah, I think this was the code for it. Take n as input and print n minus 1.
So anybody in the chat who was like not able to do this one? Need two hints for it.
I think probably we can move to the next problem then. Next problem says normal problem. A string consists of two characters P, Q, and W. Only characters P, Q, and W is painted on a glass wall of a store. Sip walks past the store, standing directly in front of the glass and observes string A. Then Sip heads inside the store, looks directly at the glass window, and observes string B. Sip gives you string A. Your job is to find and output string B. So, like, the idea is probably like we have been given a string, and we have to see like what happens if we look at on from the opposite side of the mirror here. And probably, for example, like P, P, W, Q, Q. like this was one of the samples, and if you look at the samples, you will realize that P changes to Q, W remains W, and Q changes to P when you flip it across the mirror. And like that was my first attempt. Like I just changes P and Q. Then I realized like that also fails in the sample. We have to also reverse the string because right now we are reading
Exactly
from
what I did.
from
That's
right to left
exactly
and left to right. Like
that's exactly what I did. First, I
mm,
just changed P and Q. I just swapped P and Q and tried to run it on my sample cases, but it was still wrong. So I realized I have to reverse it as well.
mm, yeah, because when I looked at first two samples. PWQ
Yeah,
become PWP and PPP
exactly.
becomes
Exactly.
QQQ. So I just wrote that and then I
I
realized
think
sample is failing. So reverse was also the case.
I think that's the
Mm.
thing about these first two, three problems of Div 4, or maybe the first two problems of Div 3. It's that you kind of have to. Oh, I'm getting. Anyway, yeah. So you kind of have to just decipher what you have to do from the sample input output so that you can solve it in 2 or 3 minutes. Yeah. Otherwise, like if you. A lot of times the statements are confusing and they try to convolute it in some way. So yeah, you have to kind of avoid that.
Yeah. And essentially, this was the solution I had. W remains W, P changes to Q, Q changes to P, and then also we have to also reverse the string. So,
Yeah.
any questions, anyone from this question or any questions from demoralizer before we probably move to the next problem?
RNC uses
Mm.
Arch. Oh,
Okay, I think with no questions, I will probably move to the next problem and we can take more questions after the third problem. Third problem says Ball is teacher in Paperfold University. The seats of his classroom are arranged in two rows and M seats. Ball is teaching A plus B plus C monkeys and he wants to assign as many monkeys to seat as possible. Ball knows that A of them only want to sit in row 1, B of them only want to sit in row B, and C of them have no preferences. Only one monkey can sit in each seat and each monkey's preference must be followed if it is seated. So essentially we have three different type of people.
yeah.
Like we have first M rows in the first seat, M rows in the second seat. We have A people who want to just sit here. We have B people who want to just sit here, and remaining C can sit anywhere, wherever we want. So, like, probably the idea was like first make people sit who have specific preferences. For example,
Um,
from
People are saying that there were casework and edge cases in the comments in the
mm,
live chat. People are saying all that,
yeah,
but in my solution there were no cases, and I
yeah,
guess that was the same in yours
mm,
as well, right?
yeah, like that was my solution as well. Yeah, like essentially the idea is first let's try to make A people sit on the first row.
Yeah.
And like for example, some people may sit over here as well. And I think the case what people are mentioning here is like when A is greater than M, when they have probably overflown hit over here. So the idea there was to do A equal to minimum of A comma M. Like these are the maximum type of people of type 1 which can sit in the first row. So
Yes.
and similarly we can do like we can try to make people of type B sit in the second row as many people as we want. And we can also do B equal to minimum of M comma B,
Yes.
because if number of type B people are more than M, then we won't be able to accommodate them anywhere here. Now let's say like once we do this, we no longer need those if cases we have.
Yeah.
And now the idea is like A people, first A people will sit somewhere like this. Next B people would sit somewhere like this. And for all the remaining places, we can try to make people C sit over there. And the
Yeah.
idea would be like if we have some extra people, then we don't have to make them sit anywhere. So the idea would be like the answer would be minimum of total. First, we need to do these two things. Then total number of people. Then A plus B plus C. If we have more than 2m people, then we don't have to sit anywhere here. And essentially, that was the main idea we had here.
Yeah. Oh, that's a good point. Oh,
Hmm. So,
actually, what I think what Paris has written in the chat, that's the same thing that I had done.
hmm,
The contribution of
hmm,
C, I took it as 2m minus A minus B comma C. But what you did is actually better. The answer is just A plus B plus C
hmm,
and the minimum of that or
hmm.
2m.
Yeah, like
Yeah,
the idea is like we can even in fact prove both the things are equivalent. What you
yeah,
did
they're
was
the same.
A plus B.
Aryan,
pl-
can
pl-
you zoom the solution, the code, and like bring it in the middle? The people in the chat are saying that
hmm,
our videos are kind of blocking the solution.
Okay, I think I can try.
You
I
can,
can.
I think, zoom in it and bring it in the middle.
I think is this better?
Oh, wow.
Mhm. I'm trying just to
Oh,
prepare.
wow.
So,
So,
hmm,
are you on a desktop or a laptop?
laptop.
On the laptop, you can do that pinch to zoom thing, and
No, but I don't have macOS. I think
oh, okay.
that works on Mac.
Sad.
Mhm.
Okay.
Yeah, so essentially we can in fact prove both the things are equivalent. Like what demoralizer did was remaining places for C, comma C. And what we can do is like we can just add A plus B in both the values over here. So like this value is equal to minimum of, like either you find minimum of two values and add something to it, or you can add something to both the values and find minimum of them. So
Yeah.
it will become 2m comma A plus B plus C. Any questions, anyone, before we move to the next problem?
I mean, now I see it intuitively as well that if C is more than required, then we will be able to fill all the seats. So it will be 2M.
Right.
Yeah.
Okay.
Okay, let's go to D, I guess now.
Okay, let's go for D.
I actually forgot what D was.
Yeah. Okay. Yeah. This was nice one. If I look at it in retrospect, it says
Oh,
given. Yeah.
yeah, this was very interesting. D was very interesting. I was actually confused for like 2 minutes. Is it even possible or not?
Yeah, and in fact, for D, I even went on to the next problem before I came back. So let's just read D once. Given a sequence of positive integers, a positive integer is called a mode of sequence if it occurs maximum number of times.
Can you wait for 1 second?
Hmm.
Yeah. So can you like on the chat, the people who were not able to solve this problem and spent like a lot of minutes or maybe hours on this, can you tell uh, like just the people who weren't able to solve? Yeah.
Okay,
Okay.
so
Let's go on.
okay, let's just read the problem once
One
and
hour. Someone said that they spent 1 hour on this problem.
then. Yeah. So it says we skip mod of a sequence is it up if it occurs maximum number of times, and in fact it even next clarifies. For example, mode of 223 is 2 because you see 2 appears 2 times and no other integer appears more than 2 times. But then it also says any of 987 can be considered to be mod of sequence 998877. The idea here is like everything does appears 2 times, nothing appears more than 2 times. You have you gave UFO an array of length n. To thank you, UFO decided to construct another array B of length n such that AI is mod of sequence B1 to Bi. Like basically, we have to find some sequence B1 to Bn such that we know that the mod of first I element would be AI over here, and that's what is given to you. However, UFO does not know how to construct B, so you must help her. Note that Bi should be between 1 to n, must hold for any array we want. And if one looks at some sample example, it says 112. If we take array 112, mod of first array is 1. So we have 1. And then we have 1, 2. Like anything 1 and 2 is acceptable here. So 2 is also fine here. Now we also have 1, 1, 2, 2. If you look at the first two elements, they are just 1. So their mode will also be 1. And now if you look at the first three element, 2 appears only once and 1 appears 2 times. So here also the mod is 1. And if you look at all the four elements, 2 appears 2 times, 2 appears 1 time. So 1 and 2, both of them can be mod here. So 2 is acceptable here. So
So Aryan, what do you think was the most important hint in the problem statement? Like a lot of people must have just missed that. So
yes.
what do you think is the most important hint here?
So I think let's probably look at this way. Like, let's say we have constructed some array,
Hmm.
and this array has some mod to it. And if
Right.
we add one more element to it, either the number of times that a element appears should be equal to the maximum frequency of any element so far, or it should be
Hmm.
more than that. And now the most important hint I think is any of 987 can be considered mod of this sequence. This was one hint. And that essentially next time when I read this problem, I realized what I can do is I can just ensure that each element appears only once. So like all
Right.
the elements which have appeared so far, would all of them would be mod here, and this gives me more flexibility here.
Exactly. So I think the hint that helped me the most, which also could work as an advice for the viewers, is that you should always read the constraints very carefully. So here you can see that the length of the array is 1 to n, and the numbers that we will print will also be in the range of 1 to n. So what we can do is we can print each number once and sort of make it a permutation so that every number that I have printed till now becomes the mode of the sequence. So that really, and I guess if I hadn't read the constraints carefully, I would have missed this solution.
Yeah, and from my side, it required some non-trivial effort to even print the permutation here. Like, had this was not the constraint, I would have printed 10 to the power 9, 10 to the power 8, something whenever each element has appeared once.
Oh, nice.
Yes.
I think the problem was that what if, I mean, usually that's not how it works in Codeforces constraints. But yeah, the problem was what if basically the size of the uh, like if the size of the array is bigger than the range in which we can print elements, then that's the problem.
Right. Yeah, for example, if we look at this array 100, 1012, for
Yeah,
this also this A is valid here. But
yeah,
now because we need each BI between 1 to 4 because there are 4 elements. So I cannot just keep arbitrary number here. I will have to probably put 3 and 4 here, or any order
yeah.
works. So the main idea over here was like we will keep each element only once.
Hmm.
Only once. And the next thing we would do is we can basically, if for example an element appears, let's say 1 2 5 6 2 10 and few more elements like this. So before this 6 appears in array A, we should put that 6 anywhere before anywhere here, and we should be good. And
Yeah.
because we will keep each element only once, so all the elements we have filled so far would in fact be the mod over there. And essentially that was the idea. Implementation wise, I think people can try out multiple things here. So what I did was like when it like any questions on the idea first before we jump on to the solution here. Like basically how to code it. Okay, can you explain once? Sure. So like basically our idea is, I think for the second sample we had I think 1 1 1 2 and 1 1 1 2. I think this is not the best example we have. I think let's pick this as A and this as B. 1 3 4 2. So the idea is if I look at for I equal to 1, this would be my array B, and the valid mod here is only 1 over here because it appears only once time. So A1 is 1 here. Now let's look at I equal to 2. I have two elements 1 comma 3, both of them appears only once. So both of them can be mod here. Like both are valid mod here. And because we have one here, like this is fine here. Now let's look at the first three elements here, which are 1, 3, 4. Each element appears once, only once. So whatever you take over here will always be the mod here. So any of 1, 3, 4 would be an acceptable mod here. And we have one here, so that's also fine. Now we have 1, 3, 4, 2. Each of them appears only once. So we are probably good here as well. And essentially that was the idea. Like I think one thing which most people have missed out over here was you can in fact take any element which is not present in starting array but is between 1 to n as well in the solution. Like 1 1 2 1 2 gives you an impression that you should only pick element which have appeared so far here,
Yeah.
and that makes this problem hard because so far here you would end up with just one or something like that, but you can in fact put 3 and 4 here so that each element appears exactly. And I think this was the main idea I had, and probably the solution can be like you first iterate over all the elements given in the input, put them in that order in your code, and then you put all the elements which have not appeared so far into the array. Okay, dry run third example. Yeah, like it's quite a big one. I think I will just
Yeah, we
take
can
it.
we can go to the code, I guess.
Yeah, I think code might be more easy. I think not the good code I had, but that's
I think you can show my code also. The solution
mm,
is a little different.
okay. Let me just open
I can send you the link.
it. I think I will have it on scoreboard.
Oh, right.
Mhm.
Yeah. I must be in your friends.
Yeah.
D. It's D, I think.
Yes, it's due. So yeah, his solution is like he took A as input, I and P array, which basically takes array A in vector input. Now he also has a set. He has inserted all the numbers which appear in array in the set. Now he has a permutation. Like basically, if you print each element only once and between 1 to n, you call it a permutation. So he now also has T, and he has inserted all the elements in T as well. Now we are iterating from all the elements from 1 to A. If you already use some element X, no, one second. So,
The solution is not the same as yours. So what I
mm,
have done is I have taken the unique elements from the input array, and without destroying their relative order, I put them in the permutation, and then I put the remaining elements in the permutation.
yeah,
And I guess,
that's actually nice.
yeah.
So, for example, what you did was like let's just pick this 1 1 2 example as well. So we have 1 1 1 2. What he did was when he iterated over here, he first took 1, put 1 in the array B. Then if 1 appears, he ignored it. 1 because we already added, he ignored it. Now 2 appears, he has added 2 here. That's how he added all the numbers so far, all the unique numbers which have appeared over here. And all the numbers that has not appeared so far, he had added remaining numbers like this over in any order we want. And that also essentially does like works. And any questions, anyone, before we move on to the next problem? And yeah, like missing constraint can give you a hit and miss for this problem.
Exactly.
Okay, I think
Exactly.
any questions on problem D before we move to next problem? Yeah, like
Can you
probably.
can you show the code once? Some people I think want me to explain it a little.
Sure.
Okay, I think it should be clear. The problem might be that I'm using a few macros, so maybe that's the problem.
I think I
How
can
to
just dry run it once.
how to
Uh,
insert remaining elements? So basically, I've used set t, and inside set t, I have all the elements. And once I keep putting them into the permutation, I remove it from the set t, and then I put everything in set t into the permutation. So that's that.
let's say this is one input. We have been given this A, which is 4334. Utkarsh has initially created, I think, do we need status here?
The s will just be 3 and 4. Yeah.
Okay, so first he created all the numbers which appear over here in status, which is 3 and 4. And set T contained all the numbers from 1 to n. Now he is creating array B. He first looked at the number 4.
Yes.
This number 4 still exists in set 4. So he removed it from here and added 4 here. We are good here. Now he moved on to the next element 3. 3 appears in set S. So he removed it from here. He removed it from here too. Now we have 3 here, but this 3 is not present in set S now. So he did not do anything over here. Now we had 4 as well. 4 is not present in set S, so he did not do anything over here. So after the end of this loop, he had B, 4 and 3. And after this end of loop, we just have 4 and 3 with us. Now what he did was, for the remaining elements in T, he added in whatever order they are present over here, which is just 1. So this is what he did.
Yeah.
Yeah. Any question, anyone?
I think we can move forward now.
Yeah, okay.
And that was a very good dry run, very beautiful explanation.
Yeah, and I think we can probably move to problem E. Yeah, problem E says insane problem. Wave is given integers k, L1, R1, L2, R2. Wave wants you to help her count the number of orders pair x and y such that the following are satisfied. X is between L1, R1, y is between L2, R2, and there exists a non-negative integer k such that y by k is equal to k to the power n. Don't we need ordered pair, unordered? I think unordered pair also works here because y would
With
always be greater than x because it is non-negative integer n.
I think with the unordered there will be a problem with k equal to 1.
No, when k is equal to 1, x equal to y always happens.
Yeah. Okay.
Yeah.
Yeah, doesn't matter.
Yeah, so disordered, you are right, Kerry. Ordered does not matter.
Yeah, correct.
And any idea, anyone, like this looks like n can be anything, right? N can even be infinity here if you look at apparently. So any idea, anyone in the chat, or what did you do?
Now, there's some idea in the chat by I think Deva Priyan. Let's read it once.
Okay. For E, can you try solving it from backward? That is, we calculate number of pairs for x1 and y1, and we can assume answer exists between these two range and try to figure out. Okay, but my problem is we cannot iterate over all x1, y1, right? Because we have 10 to the power 4 test cases and LR can be up to 10 to the power 9.
Yeah. I
And
think the first observation here was that the value of n cannot be more than 30. So I think everybody must have figured that out.
yeah, like that was, I think, the first observation I also had. Like, for example, let's say we have x equal to 1, k equal to, sorry, and k is always greater than equal to 1, greater than equal to 2. And let's say we say n equal to 30 we have. Then y by x equal to k to the power n implies y equal to 2 to the power 30, which is more than 10 to the power 9 we have. So, and because R2 is less than 10 to the power 9, this gives us with only 30 different choices for n over here. Like we cannot have more powers here. And the next idea I had was probably, my idea was we can just maintain one variable let's say pk, the current power of k we are considering. We can start with 1, we can keep multiplying it by k, so on, as long as this variable pk is less than equal to r2. Now the idea was like once we have fixed some power of k here, y by x, let's say is pk, we can revert it the other way around. It gives us x equal to y by pk. And using this, we can, if we know that y is between, now
Aryan?
if we know x equal to y by pk, then if we know that y is between r2 and l2, then we can divide it by pk here essentially. This will give, and now we can replace this by x. And we have another constant that x is between r1 and l1. So now we can find all the numbers which are common between those two elements, these two ranges, and we can print that. And I think essentially that was the solution I had. And you can probably just ignore log factors, etc. over here. Like you may have precision issue there. Like this can be completely done between integers.
Yeah,
Like
it can be done with integers.
here you should take seal,
Yeah. One has to be C, other has to
and
be floor.
this one should be floor.
I, I
And
think yeah, other one is
and
floor. Yeah.
yeah, and then you can take maximum value of minimum element you can have and minimum value of maximum element you have. And if they have non-zero element, you can print that in. Yeah, I can repeat once. I think the first observation we had was like, let's look at the worst case. What can be maximum possible? And in the worst case, we have x equal to 1. Because we have k equal greater than equal to 2, let's look at what happens when n is equal to 30. Y by x equal to k to the power n. K is 2, n is 30, x is 1. So y becomes 2 to the power 30, which is more than 10 to the power 9. So this gives us some idea that the number of values of n we want cannot be very large over here. It's most of the time it will be between 0 to 30. And when k increases, it will even decrease further over here. Then the next idea was like, let's fix a power of k here. We start with 1, k square until as long as p power of k is less than equal to r2. Now once we have fixed some power of k, now we have fixed essentially n. So our equation changes to y by x equal to p of k. If you manipulate it, change like move x further side, pk downside, you will get x equal to y by pk. Now, like because we know that y is between L2 and R2, let's just divide it by pk over here to get possible range of x over here. So now we have like L2 by pk and R2 by pk. Like here the idea was you should take seal, here you should take floor. The main crux of the idea is like, let's say for example we have pk equal to 8 and L2 equal to 10. And let's say k is 2, n is 3. Then 10 by 8, you cannot take x equal to 1 here. Because if you take x equal to 1, you will get y equal to 8. But if you take x equal to 2, you will get y equal to 16. And that was the reason why we needed floor seal over here. Like for example, if you have 10 is greater than equal to y is greater than equal to 26 and 10 by 8 which is around 1.25, this is around
So I think
3.25.
right. So I
And
think a lot of people are asking why we're taking seal and floor. So yeah, so the way I thought of it was that yeah. So when we divide our whatever p to power sorry k to power n from L2 and R2, right? So we want the range of x, right? So we want basically it should be L2 divided by k to power n, and we want something greater than that, right? Greater or equal to that. So to do that, we need to seal it, because like if we get, like for example here we have 1.25, right? So if we don't seal it and if we floor it, then it will be a 1, and 1 is not um, in our correct range. So we must do it. We must seal the lower limit and must floor the upper limit. Then only we'll get the correct range
Let's
of
say we have constraint like this: x is between 1 to 10, y is between 10 to 26. If you just take floor here 1.25, you make it 1, then x is fine, but 1 when multiplied by 8 becomes 8, and you want y to be at least 10 here. And that was the whole reason why you should change lower bound, you should increase it to the next integer, you are essentially a float here, and here you should decrease it to the nearby integer. So this will give us like x should be between 2 to 3, this has x between 1 to 10, and if you look at ranges between them, you will get the required number.
yeah. I don't think it's much math. The way I see it, I can like I just visualized it. You just have to, bring the lower limit up and the upper limit down so that it's more restrictive that way. So that was just intuition to me.
So essentially this was the solution, like take everything as input. Now number of solution as answer and current power we are considering. As long as current power is less than equal to R2. Now the two possible ranges of x you can have is R1 and R2 by current, which would be the seal here. And for the lower bound, we can take L1 based on the constraint on x, and here we need a seal here. You can probably not directly use the library function, and it's some non-trivial way to find seal here. And now if you have some non-zero elements between this range, then you add all the elements you had in this range and you multiply current value by k. And whatever count you have got, you have printed it in the end. Any questions, anyone over here before we move to the next problem? Like I think binary search was essentially just finding this range which we have direct formula for.
Yeah, we can do it in O1, so it's not necessary. I guess we can move to the next problem.
I think we can move to problem F now. Problem N is easy demon problem. For an arbitrary grid, robot defines its beauty to be sum of elements in the grid. Robot gives you an array A of length n and an array B of length m. You have to construct a n cross m grid such that ijth element would be ai multiplied by bj. Then robot gives you q queries. Each consists of single integer x. For each query, determine whether or not is it possible to perform following operation exactly once on m so that the beauty is x. Choose two integers r and c and set mij to be 0 for ordered pair ij, where I basically set every element in rth row and jth column to be 0, and then you take sum of all the elements again. Note that queries are not persistence, meaning that you don't have to actually change values for the next step. Like basically for each given x, you should find the next independently of what problems were asked before. Yes, an order of n into m will definitely TLE.
Yeah.
And I think like the thing I abused the most over here was like x would be between 2 into 10 to the power 5, not more than
So
that.
what was the time complexity of your solution, Aryan?
My time complexity I think was around, like let's say let's define this as the maximum element.
Yeah.
Then I think my complexity was max into log max, something like that. It was sieve like loop, not exactly
Uh,
sieve, but yeah.
okay. Yeah, Sieve. I didn't do that actually, so that's why I
Mm,
took more time. So what I did was I was doing the factors on every query. So it was root into log, and then I tried to remove the log of the set
okay.
um by noticing, like if you notice the fact that basically you can remove the set with an array.
Okay, yeah, I got it now. Like
Yeah.
because
So
your whole formula at the end of the day is some of elements of A into some of the elements of B. After you
yeah,
change something into X, this becomes
so
X.
we can basically remove the set completely. So yeah, I think I didn't do the other optimization. I knew about it, but I don't know why I didn't do it. It must have been faster.
And I
But
think
yeah,
this
you can
one is
do.
actually better. And what
Yeah.
I did was some non-trivial manipulations,
No,
assuming some element is removed. Yeah.
I think yours was better. Basically, I guess it's easier that way. You can just like basically what you did was in n log n you got the all the factors of all the numbers.
No, I
So I
think
think
I did not even use the fact that we can look at factor to find SA and SB.
oh,
So it was
okay.
something way off for me. Like the way probably I think we can first look at demoralizer solution, then I can probably say what I did.
Oh,
So
okay. I'll tell you my solution. So basically, if you go back to the problem statement, um, if you notice that like whatever that matrix we are given, uh, right? So the beauty, right? So
right.
the beauty is just the sum of all the elements from the first array multiplied by sum of all the elements on the second array, right? So once you notice that, it becomes kind of easier.
So like
Yeah.
essentially the idea is if you look at A1 plus A2 plus A3 plus A4, take this value and multiply this value by B1 plus B2 plus B3 plus B4. Now you can notice that if you multiply these two numbers, you will get all the numbers AI, AJ, BJ.
Yeah, exactly. And basically, when it says you have to remove exactly one row and one column, right? So that just means that if you like, if you try to visualize it, if you remove a row and a column from the matrix and kind of condense the remaining things, then you'll see, yeah, exactly what Aaron has done. You just remove two of these elements from the sums. So right, so basically it's just like the sum of all elements minus one of them multiplied by the same thing on the other array. So
So,
when we do this,
so
we
like
want
now
to get,
demoralizer's idea was let's fix X. Now it's the formula of essentially is the sum of elements of A multiplied by sum of elements of B. So based on the factors of X, you can fix one of the value here. Let's say this one, and then you will essentially have the other value as well. You know the original sum as well, so you can essentially look at original sum, deleted element. The idea is basically deleted element in A would be sum of elements of A minus the new sum you have fixed. So his idea was now you uniquely know which element should be deleted over here. Then you probably checked using SAT or something if this element exists in A or not.
yeah,
And I
yeah.
think probably to remove the log factor, you can just maintain one array of size 4 into 10 to the power 5 and check in constant time.
Oh, I think you just need an array of size 2 into n plus 1.
Right, yes. Basically, whatever the maximum value in A was.
Yeah, yeah. I
So,
think the values can be negative also. So what I did was
shift by n.
shift by n. Yeah,
Yeah.
exactly.
Yeah, I
So
also did shift by n, and I think my solution was more complex. Really.
yeah,
And I think this is more easier to understand. Any questions,
I,
anyone here? And I think
I
we.
think what people will miss here is that when you take the factors of x, let's say I have you just have to iterate till root n, right? So when you take the factors, yeah, please open my solution. That would be great. So yeah,
Mm.
when you take the factors, you have to consider the pair. Let's say I have the two factors I and j. So I have to consider I and j, and also j and I, and also minus I
Minus
and
I
minus
minus
j.
A. Yes.
Yeah, so we have to consider all of that.
And I
Yeah,
think
basically.
you can also pre-compute all the x that is possible using a sieve-like loop.
Yeah, yeah.
So you don't
That
have to
we have.
every time iterate until square root of n.
Yes, then that will just become cube root of n, because the
Mm.
maximum number of factors that a number can have is just cube root of that number.
No, idea was like if you look at count of factors of all the elements from 1 to n,
Yeah.
then that's essentially n log n only.
Yeah,
Like
that I get, but what if the query is the bad element every time?
so you can, yeah, now you can memorize it.
Oh, you can memorize it. Okay. Oh, okay. Yeah.
Mm.
Yeah, that works. That works.
Yeah, I think this was demoralizer solution here. He took A and B as input here. Some limit
I think
0.
I think you can just go to the loop. I made a lambda, and
Mm. Okay,
you can just,
okay. You have this function check,
yeah.
which checks if two ele- I can be possible sum for A and J can be possible sum for B, or like probably you can only explain what's here.
Yeah, basically, even I don't exactly remember, but yeah, what I did was, right. So I made a function check, and what check does is, yeah, it checks whether the pair I comma j works or not, right? So I check two times for ij and for ji, and yeah, the way it works, the way check works is a little complex, but like, you can like basically use a set. It is a sort of optimized version of that. I used a vector instead of a set, so that can make it a little complex. But the if you go to the inner loop of the solution, then that is pretty simple. I just check for I and j and minus I and minus j. That's it.
So any question, anyone? Like I think the main idea here is you have x. Look at one of the factor of x. So you now uniquely know the sum of elements of what A should be, sum of elements of B should be. Now you look at the original sum, check their difference to see which number you should delete from the original sum to get the new sum. And now you check that original sum appears in the original array or not. This was the crux of the problem. Now to reduce the time complexity, you have all sort of ways to probably run a sieve like loop first, and probably, and I think
Uh,
we are back now. So looks like
Nice.
I had internet disconnection.
I'll ask the chat if we're back up.
Mm. Okay, I think we are back now. So basically, internet disconnection in one more. Probably router started, or I don't know, but that's where we are. Yeah, I think what I was saying was the essential idea for this problem was you fix one factor of x, call it as sum of a, and you now have a force value of what sum of elements of b should be. Now, based on what sum of elements of a you want and what sum of elements of a already exists, based on difference of them, you can find out what element you should delete over here. And the next step is you check if that element is present in A or not. This was the main
Yeah.
idea of this problem. And then now you have all sort of optimizations to reduce time complexities here. And I
So
think in the best case, this can probably be done in around mx log mx complexity, where mx is maximum possible value of x, which is 2 into 10 to the power 5. And with this time complexity, you can essentially pre-compute what all possible values of x can exist over here. And then you can just take that in constant time to print all the values you have. Any questions, anyone, on this problem before we move on to the next problem?
nice. So what was your solution, Aryan?
My
Was it the
solution
same
was
as mine?
no. My solution was essentially, let's say we have removed an element A from original set A,
Okay.
and element B from original set B. Now I iterated on all the elements of A to fix X,
Okay.
and like at first I did not even had X. What I did
Yeah.
was I pre-computed what all possible values of X can be.
Okay.
So like let's say let's call element deleted from X as Y
Yeah.
and element deleted from B as X.
Let's not use X and Y. Just
Okay.
call them P and Q, I guess.
I think okay. PQ. Now my idea was to first expand this term, which gives me XB into XA minus P
Yeah.
plus Q into XQ XB X, and I think this is P minus SA. Like the sign has been reverted from plus sign here. I have multiplied over here. And if I have fixed value of P, you see this equation looks like MQ plus C. This is a straight line for whatever values of Q we have.
Oh, okay.
And then my idea was probably because we want this to be between maximum value we have, we can essentially find the bounds of Q over here, which essentially looks more like move C outside than divide by M.
Mm-hmm.
And then I had was like the number, now I can just iterate on all the possible values of Q we have over here between the given range of A and B. And the idea was number of such iteration would still be bounded by log mx into log max.
Right.
And the
Makes
critical optimization over here was like same element can be repeated multiple times in A, so you have to just iterate it only once. So after finding sum of elements of A and B, you just make the array unique first.
okay.
Yeah.
Yeah.
Any so that was what I had. Any questions anyone on problem F before we move on to the next problem?
G1 and G2 were like very nice.
Hmm.
I really enjoyed
Yeah, like
solving.
I in fact like stress tested G2 to find the
Oh,
counter test cases there.
so
And
I actually did G2 first. Like the moment I read both the problems, I knew exactly
hmm.
what's the difference between them. So I was lucky regarding that, then it was just implementation for me. I saw you had like 7 or 8 wrong submissions in
Yeah, like
G2.
after first three wrong submission, I started suspecting like whether RI equal to I is correct or not. So one, two submissions were assert there,
I
and
actually didn't use topo sort. I don't understand what's the topo sort solution, but what I did use was a very I used a very good, very interesting thing in the G1 G2 solution.
I think like
Uh,
let's probably just read the problem once. A group of ant spiders have come together to exchange plushies. Initially, each spider has one plushie. Every year, if each spider has at least one plushie, he will give exactly one plushie to spider RI. Otherwise, he will do nothing. Note that all plushies together transfer happen at the same time. In this version, if a spider has more than one plushie at any point of time, they will throw all but one. So if I have more, let's say more than 10 plushies at a time, I will throw away 9 of them and give the remaining one to the next person. And this is the difference from the next problem. In next problem, you give one and you keep all the 9 with you still. The process is stable if like this table also was slightly confusing. But for now, let's say earlier, we will stop transferring these gifts whenever like after you, it does not make any changes over here. So for example, if I look at the samples here, initially everyone has one of them. After first iteration, like this guy does not have anything, but everyone else has one. After you do some more iteration, this guy also no longer has that. And now you have 1100. And now if you do exchange, like these two guys keep exchanging stuff between them. So this array remains constant. So the idea was found after how many iterations the value would become constant, like there would no longer be any changes. And essentially that was the crux of this problem, and difference between this version was if you have more than one, you can keep more than one gift with you for you. So now you see in the same array here it has become 14000. So that was the problem statement. Any questions, anyone on the problem statement? And I think because I will let you explain this problem, and I can
Oh,
help with
nice.
visualization here.
Yeah, I think the first part, like I usually read the harder version first, right? So whenever I'm attempting div 3 or 4 or mostly even 2 also, I read the harder version first, right? So because usually they are the same problem with different constraints, but in this one the problems were actually different. So yeah, anyway, so I think the first thing to notice here was how the graph will be formed, right? So
So I think we can take one of the sample tests here.
yeah,
So let's
yeah,
pick this
basically,
41154.
okay. I mean, yeah, you can like just hold on a second. So yeah, the viewers, maybe you can try to take the sample test case and make a graph from that, and yeah, you will likely see some pattern there. But I saw the pattern theoretically, because like I didn't have any pen paper or anything, so you can actually see the pattern theoretically as well. So you can see that there are n basically in every sort of weakly connected component. In every weakly connected component, there will be, let's say, if there are n nodes, there will also be n edges, right? So there's one edge going out from every vertex, right? So when the number of vertices and edges are equal, then there is exactly one cycle in that graph, and everything else is sort of like a tree. So
Yeah, I think there is a name for it. Functional graph was the one. And you see in
yeah,
this example, the cycle is here,
yeah,
and everything hanging here is kind of tree here.
yeah.
And
So
that's what you are
Aryan,
saying. Okay.
yeah, Aryan, can you draw a general version of this? Like, let's just say I have like I have like a cycle in between, and then from every node of that cycle, there can be a few trees attached there, right? Right. So that's how the general version of the graph will be. You will have sort of like a maybe any size of cycle, and then from every vertex of the cycle, there can be a few trees there. Yeah, functional graph. It's called functional graph as well, right?
Yeah.
And then there can be multiple connected components, and in every component there will be the same thing. Actually, you can also draw one more case. Like from the same vertex, there can be two disjoint trees as well.
Right. And I think this was something I missed in this problem.
Oh, oh, oh,
Mm.
oh, that's sad.
Yeah, because
Oh,
like
that is not
I
the case
was
you were.
taking just some over here.
Oh, I get it. That's why
Mm.
you got so many wrong submissions in
Yeah.
G2.
Yeah. So yeah, this is how this graph looks like.
Yeah. Or okay, so I think this is good enough for G1, but for G2, I would want there to be some sort of branching also in the subtrees. Like, can you make an extra branch here? Yeah.
Mm.
Yeah, so basically now what we have is the most general uh, form of graph that there would be. So you can see we have multiple connected components here. Each connected component has sort of like a central cycle, and then there are some trees attached to that central cycle. And then in all of those trees, there can be some sort of branching, there can be subtrees, and then from a single node, there can be multiple trees attached. So yeah, so you have to make the general graph, right? And you can make that just theoretically. You don't have to examine the test cases as well. I didn't have any sort of pen and paper, but still I was able to make this exact graph in my head, right? So now let's see what's going to happen. So if you see on this graph, if we have let's say a red dot. A red dot is a plush. Everybody has one plush in the beginning, and they are giving it to the next person, and this will keep on happening, and we have to see when it sort of becomes stable. And stable means that nobody the number of plush that anybody has does not change. So what we can see in problem G1, if anybody gets like extra plushes, then they throw it away, so everyone will have just one plush. And like if you look at it carefully, the uh, the basically the number of turns that it will take for it to become stable. So basically, how will a stable graph look? So everything, all the plushes will be present inside the cycle only, right? So all the plushes have to be present inside the cycle only, and all the trees have to be empty, because we know that after, let's say, after infinite steps, obviously all the trees will be empty, um, because they are sort of giving their plush away, and they are sort of getting dead. I'm calling them dead because they are not participating in the problem anymore, right? So they're not getting plushes from anyone, and they are giving their own plush away. So then they sort of die, and then their parent now becomes a leaf. Then and one by one the leaves will keep on dying, right? So at the end, only the cycle will remain, and only the cycle will have all the plushes, right? So when will this happen? And that is just so that is just the depth of the subtrees that are present. So you just have to see all the subtrees that are there, and you see the depth basically, or the height of those trees, and basically the tallest one will give you the answer. So the tallest subtree, yeah, maybe Aryan, you can point out the tallest subtree,
Yeah.
and you can show how
Yeah.
giving
So
the.
basically, TLDR was like what he was saying was once people, if we have a graph like this where green arrow denotes who is giving plus to whom. So after you see, after some time, only these cycles people will keep exchanging pluses between them, and everyone else will not have anything with them. And the idea was like in G1, like this guy gives his plus here, so he no longer has it. Next time this guy gives here, next time this gives here. So after three exchanges, no one over here will have anything with them. So you have to find like who is the farthest person from the cycles like this. Here in this case, this is the guy here. So that's why the answer was after three exchanges, everyone will have constant number of pluses, and you needed some plus to satisfy the problem statement's definition there. Like it was written in way non-trivial way. The number of year is number of people just before it, and that's why. So any questions on G1, and then we can move to G2, I think.
Actually, my implementation was very good. So I wanted to like very, I won't say very good, but very interesting to me. So I want to ask you, Aryan, and also the chat, like if this is the problem that you're faced, that you have like a cycle in between and then some subtrees attached to it, find these trees. So how do
In this one, because I had the same topo sort idea. Find all the nodes with degree 0, give
okay.
their plus to the next guy, and remove them. And there would be one stage when you won't have anyone with degree 0. And essentially that was
Oh,
the height we had.
oh, nice. Okay, yeah, I guess that works.
And I
So
think like the same idea did not work in G2.
yeah, the
So
same idea did not work in G2. So actually, I read G2 first. So let's not see my solution for G1. Let's just see only your solution for G1.
okay. And I think like
Same idea works in G2.
like
Okay.
yeah, like probably you might handle branching correctly, then that works.
Okay.
Hmm.
Wow.
Oh, now I see what changes to make in my G2. Like I was looking at the value, maximum value of the person who you are giving something to, but you can just look at how much maximum pluses you had before you handed all of them to the next guy.
Like the way I saw it, in G1, we have to find the depth of the subtree, and in
Yeah.
G2, we have to find the size of the subtree.
Right.
So
And
maybe you can do the same topo sort thing to, uh, I guess, um, take the size of that.
yeah, like essentially what I was looking at was like the height of the guy who I was sending pluses over to. You can just look at height of the guy who is giving the pluses and do plus two later on.
Right.
So yeah, I think this was my idea. Maintain the degree vector of how many nodes you had. Put all those degree vector over here in one of the vectors. And as long as that vector is not empty, you increment the number of, like essentially you need number of iterations here. So now you find all the new guys who can have degree 0. Run on all these values, decrease the degree by 1, and if current degree becomes 1, move this to the new vector you have and keep doing it. And the idea was
Okay.
number of iterations plus 2. Plus 2 was to deal with the non-trivial way to find the year definition, whatever was given.
Okay. Nice.
And for the problem 2, what I started doing was instead of degree minus minus, I started also adding number of pluses y had to x over here. And then I was taking maximum for x, but if you would have taken maximum for y, that idea might have worked.
Okay.
Yeah. Yeah. So any questions,
So,
anyone? Before we probably move to G2.
so just chat whoever is present. How many of you were able to do G1 but not G2?
I think.
Because to me, like after one small observation, G1 and G2 were basically the same.
Mm,
Like especially the way I did it.
yeah. And I think for G2, I had to stress test and do everything because I missed out some cases there. So this was G1.
Yeah.
And like, I think the idea for G2 was like right now we are looking at height over here. What we need is like the size of this subtree over here.
So
And
yeah,
what,
I wanted to ask you this. How did you figure out that we need the size of the subtree?
yeah, so that's a good question actually. The idea was like once everything is on cycle, the number of pluses everyone will have will be constant. In the first statement, everyone had one. In this, we can have
Yeah.
more than one. So my idea
Yeah.
was like look at the edges which are going on to the cycle.
Yeah.
How many exchanges will happen over here?
Okay.
And like essentially, you see like for every plus which is for anywhere like here will go through by this edge only, and there will not be any cases where it would be 0 first and then become 1 on the next iteration. So
Yeah.
that was the main idea, to look at like how many times the exchanges on these edges would happen.
Yeah. So
And
the thing you said about there will be no point when it will be zero, and after that it will be one again.
yeah.
So I actually proved it using induction. So you can sort of see that it's always true for a leaf, and then let's assume it is true for like k subtrees, and then you can use it to prove that it will be true for this bigger tree also, and then that way using induction you can prove that it will be true for all trees. Isn't that cool?
Yes. And
Yeah.
essentially the idea is like you look at size of all the trees which are hanging over here, which
Yes.
is this. So any questions anyone on G2 before we move on to the edge problem, last problem for today?
So uh, Arun, did you again use that removing the elements within in degree zero idea?
I think when I first did, I was taking at the sum of this subtree whole rather than the branches here. But I think I can get the same idea working by not taking the size of this, but size of these nodes. Like I was looking at size of whoever is getting the pluses. But if I look at
Right.
the size of person who is giving the pluses, then I will just look at maximum size here and here. And
So won't
this
you
is the,
have to mark the elements that are present in the cycle in the beginning,
yes,
right?
I will need it.
So how did you do that?
No, I think for degree zero it was fine because
Yeah,
you are only looking at the element which is becoming degree zero.
yeah.
But then, like, once this idea did not work, instead of looking at the corner case here, I started looking at SCC using strongly connected component. I started finding cycles and started doing DFS from here.
Okay, yeah, that also works. So what I did was what I did was pretty cool. Like I find it pretty interesting. So I just wanted to find that one cycle, right? That's all I cared about. So I used that rabbit tortoise method, and I didn't think I'll ever use that in competitive programming, but I did it. So that was really cool.
Yeah, I think at the end of the day, I started also doing that. Yeah, I like if you look at my implementation for J2, it's very ugly. I kept running the guy until a guy has muted a node three times. And then I
Oh,
ran,
oh,
and then I ran one more cycle until the guy was fourth time. And then also I needed some non-trivial hacks to get this done. But yeah.
I actually did rabbit tortoise. If you look at my solution, that's actually
Mm,
yeah, fast pointer, slow pointer, exactly.
yeah,
Isn't
yeah,
that cool?
yes, it is.
If you look at my solution, I actually have two variables named I think tor and rab. So so I felt really good after doing that. You can look at G2 or G1, any of those. Like it's very same. My solution is same for both. So yeah, if we actually look at the code, I have tor and rab.
Mhm. Okay. First, you have
That
created a graph. Keep doing it until both of them are not equal. Now, okay, you run it once to find all the cycles, and
yeah,
then you are doing the same iteration over here to do a DFS here.
exactly. Isn't that cool?
Yes, it
I
is.
never thought I will use this thing in competitive programming, but that's really cool. Like you can find a cycle in linear time just by running
Mm,
a rabbit and tortoise,
like,
and whenever they meet,
mm,
you have the
yeah,
cycle.
like Smash in the chat said, like he never thought like people can use it to find cycle other than linked list.
Hmm, 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 hmm.
So yeah, like, and now like probably the DFS idea was to just find subtree sizes here. And earlier you were probably taking at height, max height or something like that, right? Max value. So your
Yeah,
G1 G2 difference is I think max here and plus here. So just
exactly.
yeah,
That's the only difference. So that's
yeah,
why I was able to submit them like successively.
yeah,
The graph itself is a linked list.
mm,
Yeah, it sort of is. It's a
mm,
functional graph, so it kind of is. Actually, while we're talking about this rabbit tortoise thing, we actually use it in there's an algorithm called Pollard row algorithm. So I guess it's some sort of randomized algorithm to factorize a number in I guess n to power 1 by 4 or something. Uh, yeah, so it actually uses a sort of like a rabbit tortoise thing to find cycles within the numbers or something. It's just a fun fact. I don't really know how it exactly works, but yeah,
yeah.
it's
And
a
from my
very
side, I just copy all the time from Cactal notebook.
yeah. I also copy it, but yeah,
Mm,
but I guess I read it or somewhere or watched a video or something that it does use sort of like a rabbit tortoise thing to find the cycle because otherwise if you use any other way to find a cycle since the numbers are very large you will have to make a map give an extra log factor or something but this is the linear way of doing it so it's a very good technique that we don't get to use often but today I got to use it so I'm very happy about it.
good. I think now we have the last problem for today.
Yes.
I think Swing is opening a pancake factory. Like, let's just about the story here. Swing is given an n cross n matrix containing positive integers. He has q queries to ask you. For each query, he gives you four integers x1, y1, x2, y2, and ask you to flatten the submatrix bounded by x1, y1, and x2, y2 into a formally. Like, this is some way to give it. Like, the idea is like that image actually clears out here. Like, if you look at this submatrix, that if you flatten out, the array becomes 8, 9, 13, 14, 18, 19, and this is the array. Afterwards, you have this array. You have to find ai multiplied by I for all the values over here. And now you have n up to 2000 over here, but number of queries is up to 1 is 6 over here. And I think the main idea was probably 2D suffix sums and some manipulations over there. Like, what was your idea of this?
Yeah, exactly. I used 2D prefix sums. Um, Basically, I made three different matrices for 2D prefix sums, and again, yeah, some manipulations.
I think I also had three matrices. One matrix was some prefix sums where column is multiplied by each value. One matrix was row is multiplied by each value and prefix sum
Yes.
over there. And the third one was sum of all the values. So the idea was to probably break this function over here. Like, I think I can probably just pick it over here.
Uh, Anonymous actually 2D prefix sum is like it's a very common technique. You can very easily get the sum of a submatrix using prefix sum. Yeah, AI is fine. How to compute IAI? Yeah, so I guess now Aryan will explain some very good manipulations.
So, like, I think we need this value multiplied by 1, this value multiplied by 2. I'm just writing what multiplying factor these values should have. And like, all the matrices still exist. My first idea was like probably to do it in some contribution kind of technique where I will first add these values like this. Like, I can impose it and probably more metrics exist. Like, I basically the idea is you can write these 1, 2, 3, 4, 5, 6, 7, 8, 9 multiplying factors like this. 1, 2, 3, 1, 2, 3, 1, 2, 3, and the remaining part again here. I'm not sure if this supports grid, or probably I think I can use Google Sheet or something. But
Honestly, the way I see it, like whenever I approach problems like these, I always try to solve the same problem for like a linear array, and then I try to generalize my idea from there.
okay,
So if that's how you start, you'll find it way more easier. Like that's a note to the viewers.
so like
If we try to do the same problem in in a 1D array, and then if we try to generalize that idea.
I think that's good idea. We can in fact actually, let's say we have an array from A1 to AN. We have been given some array from L to R, and we have to find like 1 into AL plus 2, 2 into AL plus 1, and so on. So basically, first element of this subarray multiplied by 1, second element multiplied by 2, and so on. The idea was like what we can do over here is like we can look at L minus 1 multiplied by all the elements AL up to AR, or probably I think I will put it the other way. We want this, right? This multiply value multiplied by 2, this 3, this 4, and all the rest multiplied by 0. The idea is you can look at this like this: 1, 2, 3, 4, 5 and so on, and then subtract this part. First subtract, I think, 1, 2, like, or basically essentially I think let's just me remove it. 2, 2 and 2. Like basically the idea is we first find for A and 2R sum of each element multiplied by original index, and then you shift that index by some value to make that L1. Like for
Yeah.
example, if you want to multiply this by 1, 2 and 3, the idea is you add with this multiply by 3, 4 and 5, and then when you want to shift this element to the first, you just look at sum of all the element, multiply by them by 2 and subtract it. So that is how you will solve it in the array. And if you want to do it in the array, you will need two things. One would be prefix sum of I multiplied by AI to deal with this part, and one you will need just the prefix sum the array, so that you just know which constant factor to multiply by all the elements, sum of elements in this array. And now when you try to do it, like, you can similarly break it into more problems here. Any questions on like how do we solve it in array first before we move to the matrix? So like this is how you do it in array, and like the same thing probably changes to matrix like this. If you want 1 2 3 4 5 6 7 8 9, you can split first into 1 2 3 1 2 3 1 2 3 and 0 0 0 3 3 3 6 6 6. Now you can use similar kind of array technique some with some prefix sum manipulations to get these values. And here, like, my idea was, if you see, if you move this multiply by 3 out, then this value is essentially 0 1 2 0 1 2 0 1 2. So now whatever you are doing with rows here, you have to essentially do it the same with columns as well.
Yes.
And then some manipulations to find all the values here. Any questions, anyone? I think I can probably jump to the implementation, or we can just start with the Q&A session.
Yeah, let's see the implementation.
So I think I solved H before G, and I think it was a good call.
Yeah,
If
for you, yes, totally.
so, I have three original vector here. Vector B is prefix sum, where each element is multiplied with which column it is in. Then vector C was each element multiplied by in which row it is, not the good variable names. And vector D was each element with just that value.
Oh.
And the idea was to convert these values into prefix sums over here. Now we have
Hmm.
x and y. So like this part essentially calculates each value multiplied by 0 1 2 0 1 2 0. No, first it's doing 0 1 2 3 the thing over here. First I am calculating this part over here, where each column is shifted by some value over here, and you have to find it between some ranges over here, multiplied by number of columns you have.
So in
This
these problems, so in problems like these, when you have like three different 2D prefix sum or stuff like that, if you make like a struct for this, you can make your code way more cleaner. Like if you look at my solution, you'll understand what I'm saying.
so this was, I
Yeah.
think, you were on the code when I was sharing.
Yeah.
So here, like this way, here I have multiplied each element by whatever column it is and some prefix sums on that column. So now I can find the value, sum of values in each range. Here I had one more prefix sum where I have multiplied each element with whatever row it was in, and then one prefix some array more where I did not multiply anything over here. And the idea was I need these three values over here to manipulate. The first thing I am doing is I am trying to find these values I had, where 0, 1, 2, 0, 1, 2, like each column is multiplied by legs, and then number of columns you have. This one handles this part. Yeah, this is kind of the subarray sum, and this is doing the shifting thing, and then this is multiplying by all the values we had. And then the next part was we need this now for each row we have, and like the similar thing for rows as well, and then some shifting here.
I actually made a struct for 2D prefix sum, and my solution is like way cleaner than this.
Okay, I
If
think
you if you take
I
a
will
look.
I will open it. I'm assuming this was here.
But yeah, it might have taken me maybe a little more time to write. Yeah.
So we have a 2D struct here, which takes a matrix and computes prefix some values over here.
And then I made a get function as well.
Get function, which finds sum of values between these rows and these columns.
Yeah. So if you look at the rest of the code, it's like very clean.
So now the rest of code, like first he took all the values as input. Temporary h is each value multiplied by the height it has. Temporary width is multiple value multiplied by the column it has. And now he has three 2D base sum, the original value multiplied by horizontal, or probably I think you can explain it better.
I think the H is horizontal, V is vertical, and then I have three 2D prefix sums, the base, the horizontal, and the vertical. And then, yeah, simply whatever we did, it's the same thing. Base is the original matrix, then hor is the horizontal. Horizontally, when we multiply, I guess 0, 1, 2, and var is the vertical one. And yeah, simple, some manipulations. That's it.
No. And I think like this code is really small compared to what I have written, and even readable as well. What you are written.
Yeah, exactly. Because I made the struct.
Yeah, this someone is asking, can this be generalized to I square AI plus AI plus C? Yeah, I think this solution can also be generalized. You will need some more values over here where J square will also be required, I square will also be required.
Oh, that's a very good question. Can it be generalized to I square AI? Yeah, I'll have to, I guess I'll have to think about it.
Yeah,
But I think I1 square minus I2 square, you can sort of uh, maybe open the brackets. It's tough, I guess, but it
like
can be done, I
I
guess.
yeah, what I'm saying is it's doable
Yeah.
because like you see like shifting is I minus C square is essentially
Yes,
I square
exactly.
minus 2CI plus C square. So this is definitely doable with I square as well. Just that you will need two more vectors here where you also need some with column square, J square. And code, this one would definitely be a bit more messy, but it's doable.
Yeah.
Yeah. I think with this, we are done with the discussion. And I will leave the chat with Utkarsh here. All the questions you have for Utkarsh. And thanks a lot, Utkarsh, for joining in today.
Yeah.
Mm,
Thanks for having
mm,
me.
mm. So, people in the chat, any questions, anyone for Utkarsh? Like,
It was a bit lag.
generally, yeah, yeah, generally, I take my questions, but this time I will let people ask you questions.
No, no, you can take your questions only. I was thinking of dropping off in maybe like 2 to 4 minutes.
I think it won't take more than 10-15 minutes.
Yeah,
I
okay,
think.
I can wait for
Mm,
maybe 5-10 minutes. Yeah.
Yeah, I think. Hello, Utkarsh sir. Did you get your current offer on campus or off campus? Can
It
you?
was like a mixture of both. I wrote the test on campus, like the placement test, but after that something came to me. I had a Google offer off campus, so I just withdrew from my placement department, from the college placements. I sent them an email that I don't want to participate, because at that time I thought Google is the best company. Why else would I want to sit in the placements if I already have the offer? So yeah, um, I was not eligible to sit for the interviews anymore, but I guess they approached me uh, indirectly because they had my resume and there was the phone number there. So yeah, that's how that worked.
Okay, the most important question is when are you starting YouTube again?
Uh, um, actually, so that's a very good question. I actually went. Arun, do you know about that Go for Gold ICPC camp?
Right, yes.
So yeah, so
And
why didn't you come first of all?
okay, so my problem was I had some releases lined up. So first
Oh,
I said I would come, but then I have to withdraw at the last moment.
it was
So
actually very, very fun.
right.
It was very fun. I went there over the weekend, so I was just going to stay like maybe 1 or 2 days, and I kind of wanted to, not spend much time on it. But when I went there, it was so fun. I ended up staying there for like 4 days. I took
Mm,
holidays. I took 2 leaves,
mm.
and yeah, it was very fun
Yeah, like
overall.
that's what I was also thinking first. Like my idea was probably to go in last 2 days, do some post contest discussion, and
Yeah.
just have fun.
No, it was
Mm,
very fun interacting with the other instructors and also the students. It was very fun, and yeah, I guess that's what kind of gave me a little bit of motivation to do all this again, because yeah, where can I find those lectures? I don't know. They were offline lectures. It was in Sonipat, I guess, and so the ICPC regional qualified teams came there to learn, and there were a lot of instructors we were teaching, and one of the instructors was Arpa. He's from Iran. You might have read about him on CP algorithms. He has a trick named after himself called Arpa's trick. So yeah, it was a really fun experience for me, and what actually kind of pushed me to maybe come back to all this, and I'm not really back yet, but yeah, what actually kind of pushed me to try to come back here was that one of the instructors told me that he started doing CP after watching my videos. So that was a
mm,
very, yeah, that was a very, I don't know what to say. It was a very special thing for me to hear. And I thought I kind of should do more of this.
And I think one question was where can I find lectures? We don't know yet. And
Yeah.
question was like I think there was one more question how to get into HFT.
HFT. Yeah,
Mm,
even I don't know how to get into HFT. I just somehow got in.
mhm.
That's all.
And then one question was Ultimate CP Podcast next edition.
Oh, wow.
Mm. So any
By the way,
plans?
regarding HFT, I think the three most important things are first year college grades, and computer science fundamentals, operating systems, computer architecture, and all, and also competitive programming. So if you have like these three, if two of these are strong, or if all three are strong, then you have a good chance of cracking HFTs.
Mhm.
Okay.
Okay, what kind of work you do on your
I'm
day-to-day work?
actually a C++ developer, and I think some of those skills are mixing with my competitive programming. As you can see, the codes I showed, I'm using lambdas and I'm using structs and all. So it is sort of like a mixture of software engineering that is coming into my competitive programming. um, Maybe it's making me slower, but it's making my codes cleaner, so I think that's a
Mm.
good thing.
One more good thing is like when you code like this, the chances of making bugs is low.
Yeah, the
So
chances of making bugs is very low because you're just writing it in
so
one place.
so like you either spend like the one good thing people often say is you either spend 5 minutes reading documentation or 10 hours debugging stuff.
Exactly,
So
exactly. And in fact, I don't think like especially in the edge problem, I think making the struct probably saved me some time as well, because instead of writing those same things 4 times, I just wrote it once. And I'm not sure, but I think I saved some time as well.
okay, one more question was like people were surprised like there actually exists job where you use CPP in day to day work.
Yeah, there are
Yeah.
actually jobs where you use CPP, and there are also some jobs where you have to use C. It's mostly when the uh, constant time optimization is like very important. So in languages like Java, Python, you cannot get constant time optimization. So when it's like in HFTs, it's all down to microseconds, it's actually down to nanoseconds. If I can optimize something that works in like 1100 nanoseconds to 1000 nanoseconds, then that's a significant optimization. So if you're using something like Java or Python, you're already very very slow. So using something like C or C++ is very good there. um, Mostly we use C++. Use ASM. Yeah, we I don't know if that's a company secret, but I guess like sometimes we actually do use um, assembly code as well. But yeah, C C is actually more helpful when you don't only have to work with the time complexity of the solution. You also want the size of the machine code to be small. So that's when C is very helpful. So if you're working on chips or operating systems, then you probably will use C. Um, I once went on a trek to Biaskund in Manali. So there I met a Qualcomm engineer, and he was telling that we have very limited storage on the chips. So they make the Qualcomm chips, and the storage on those chips is very limited. So that's why they work with the C programming language, because the solutions because the machine code size is very predictable, and that's what they have to optimize. So yeah,
One more question someone has was any tips for ICPC regionals? I
any
think
tips for
you have
ICPC?
won two regionals back in your days. Kanpur
Back
and
in my days.
yeah.
Actually, it was after my days. Like I was retired when I won the regional. But yeah, like there's not much, like I won't say it's a very different sort of practice for regionals. You just have to kind of practice comparative programming in general. ICPC is a little more uh, like there's more theory there, whereas on Codeforces there are many ad hoc problems. So I would just say if you practice old Codeforces problems, you will be better at ICPC.
Okay, and I think some people are asking like how is quant different from general software roles?
Let's not
Mm.
get into that right
Okay,
now.
okay.
A very different thing.
Okay. So I think probably
I think we're done with the questions.
yeah, yeah. I think
Most of them seem off topic.
mm,
Centroid decomposition, Aryan, I guess they're asking you to make a video on centroid decomposition. That would be
mm,
nice, I guess.
mm, I can see what I can do there. Like because so far what I have done in the channel is just two or three recorded videos. Everything else is post contest discussions.
Yeah. Centroid decomposition is a very nice technique, but I don't remember when was the last time I saw a problem actually being solved using centroid decomposition, because
Mm.
nowadays all the problems are just ad hoc.
Yeah, plus one on
interface.
that. I don't remember either. I think I just had it in my codebook because it may come in regional. That was the only
Oh,
reason I had.
centroid decomposition in general is a very very nice technique. It's a very beautiful technique. It's a divide and conquer type of technique. It's nice.
Mm, yeah. And
Ratings of problems in OA. It depends on the company. Usually, most often they don't cross 1900 or 2000, but some companies like Code Nation may go up to 2500 also.
okay, some people are also asking roadmap, and I think
Yeah.
for
Yeah.
competitive programming roadmap I have is USAO guide, which I often share with people.
Yusako guide.
Yeah, USAO guide, and
Nice.
I think first contest is running right now, and I have tried those problems until the contest, and I cannot say how many of them I was able to solve. But yeah,
Oh, nice. The standings are not public.
no standings are not public. Like basically, it's 4 hour window in 4 days.
Nice.
So you choose your window and participate in it.
That's just coordination.
Mm,
We can ignore coordination unless you want a job there. I mean, I guess it's a good company. They pay well, but yeah, it's very CP heavy. It's good for the C people, but yeah, ICPC is only in college.
yes.
Yeah, I think the questions are repetitive now. I guess I can drop off.
Okay.
It's all
So
about to
thanks,
go.
Utkas, for joining us today. And I think it's 12:30 in the night. So I
Why
think
HFT over FANG? Yeah, I guess because they pay a lot more.
uh,
Okay.
okay. Thanks a lot, Utkas, for joining us today. And I think
Yeah.
we can
Thanks for
probably
having
end this. Yeah. Bye.
me. Okay.
Yeah.
Bye.
Yeah. Bye. And thanks everyone who's here so far. And thanks for joining us today.